University of Cologne is one of Germany's oldest and largest seats of higher education. Founded in 1388, it's now among the country's excellence universities and is home to more than 50,000 students. The university has defined 6 key profile areas, including quantum matter and materials. Within that discipline, we're conducting world-leading research into organic electronics. This field includes organic solar cells and organic light-emitting diodes, or OLED technology. It's a science that touches on so many markets, including smartphones, televisions, automotive, and solid-state lighting. Where the University of Cologne is carrying out really exciting research is in the area of solution-based fabrication of OLED devices, and in particular, the invention of cross-linkable semiconductors. This technology allows us to build layer upon layer of molecules by wet chemical processes, improving both efficiency and the lifetime of devices. In addition, the cross-linking mechanism we use is light-initiated, so by locally exposing the material at each stage of production, we're able to pattern the layer. In our synthesis laboratory, we're producing a variety of cross-linkable materials with different design functions, but always with a high level of purity. This is important to reduce any device malfunction or degradation. Another new field of study is experimenting with molecular switches. These are molecules that exist in an on or an off state. Introducing these allows us to control the electric current in the device so that we can code multiple bits to store information. But synthesis is just the first step of our scientific journey. The next step is to actually test the function of these new compounds by integrating them into a device, typically by spin coating in a glove box. This will establish exactly where different molecules end up in the stack of multiple layers. Kavita Singotra is one of our PhD students.
So there are 3 reasons why this is such a great place to do my PhD. The first one is a practical application. We are not only synthesizing molecules, we are testing them. The second one is the interdisciplinary field here. Physicists, chemists, material scientists and engineers are working together. And the third one is the technology, the equipment we have here, and the technicians who support us. So these are the 3 reasons why I like to do my PhD here.
But the journey doesn't end there. Once a material has proven itself on a laboratory scale device, it has to replicate that performance on a larger scale. The Center for Organic Production Technologies, or COPT, accelerates our ideas and innovations in organic electronics into a scalable format. The center fabricates the same device but with a much larger area and using production technologies such as inkjet printing. But this process changes many parameters and we may encounter fundamental problems such as a reduced device performance. In order to solve these problems, we need to go back and analyze what is different in the larger device. One important method is electron microscopy to investigate the layer's integrity. Here you can see a defect, a bump that could have been caused by something as simple as a dust particle. Further, UV photoelectron spectroscopy allows us to investigate the electronic structure at interfaces inside the device.
So using this setup, we are able to investigate the electronic structure of devices. And this is, of course, very important for charge transport, which determines how a device is working in the end. So doing this enables us to solve problems that sometimes appear when we go from the small laboratory scale to the large scale applications. And in the end of the day, it just helps us to make better devices.
Once those problems are identified, the COP team can adjust the process parameters and improve the device performance on a production scale level. It's this kind of innovation that illustrates the collaborative power of our partnership with COPT. That synergy then creates a platform for SMEs to develop new products.
Here at the COPT, we have the opportunity to help small high-tech enterprises to adopt the university's great technology in organic and printed electronics to make everyday products. And we provide them a shell as an incubator, and they are then able to use our labs, but also offices, which then enables these small enterprises to make real business.
The ultimate goal, of course, is to create real-world products. On the ceiling of the COPT building's entrance hall is an installation built from 300 OLED lighting panels. It was our challenge to improve their efficiency and dramatically reduce their power consumption. Dr. Anne Umbach is a former process engineer at Philips involved in the optimization of these devices.
The big problem with these devices is that only 20% of the light generated inside is coming out at the front, and the rest is lost in these edges. And a simple way to improve that is to put a foil on top of it, but that makes only a small difference. What we did is we put it inside the device, and that made a huge difference. So we almost doubled the amount of light coming out at the front. In other words, the same amount of light, but only half the electricity.
We've heard a lot about OLEDs. This is a particularly interesting one because you can bend it. But OLEDs are only part of the general system of organic electronics. This is a solar cell, and this can convert indoor lighting into power for IoT or smart home devices. This is not technology for tomorrow, it is technology for today. So join us as we change the world.